We've got one more lined up. I'm your travel host today, speaking of travel, and the next visitor is going to come from Milan. So Fabio Ceruti, who's going to join us from SAS, who's going to share a use case specifically around practical GenAI applications to make better, intelligent decisions. So for the next 15 minutes, Fabio, the stage is yours.
Thank you.
Welcome.
Thank you. All right. So, hi everyone. All right. Hi everyone. I'm Fabio Ceruti, a data scientist at SAS. And in this session, I would like to walk you through some of our practical GenAI applications to make better intelligent decisions. To start, for those of you who don't know, we are SAS. So we are the leading data and AI platform with over 40 years of analytics innovation. We strive to be the most trustworthy partner that is out there. And we do this by trying to connect analytics and advocacy to create something new, better, purposeful, and lasting. Overall, we have around 12,000 employees. We operate in more than 140 countries with around 1,700 partners and 70,000 customers. In this session, we are going to talk about GenAI. And I would like to break the ice by noting that GenAI alone does not create value. Rather, making better decisions with it actually does. And when we talk about GenAI, we really need to be aware that if we want to embed some GenAI model in our organizations, we need an entire ecosystem surrounding it, making sure that every piece is there to then have the model perform and lead us to tangible business value. And speaking of value, there is a lot of value in general in the AI landscape. It is indeed estimated that the overall impact of AI worldwide is of $13 trillion US, and this could actually increase by up to 40% thanks to GenAI. So we have seen that there is a lot of value in GenAI, and we need an ecosystem around it to make sure that we can take the benefits from it. And we as SAS are there to do exactly that. We are there to provide you a platform that will allow you to reap the greatest benefits that GenAI has to offer. And when we talk about GenAI with SAS, we really have three main key pillars that we stand by. So we have our data and AI platform, that is SAS Vaya, which is there to help you explain, orchestrate, and govern large language models. We have Vaya Copilots. This is where we are headed, embedding GenAI applications into business processes. And finally, we have synthetic data generation, which is often a part of GenAI that can be overlooked, but that can particularly add a lot of value when we are modeling, for example, for rare events. And for each of those building blocks, I would like to present you some real use cases that we have worked on. So let us start by our data and AI platform. So for those of you who don't know, so our platform is called SAS Vaya. And it is an end-to-end platform designed to cover all your AI needs, all the AI lifecycle. So we take our platform and transform questions into decisions. We do this by providing you a sort of tools that will allow you to manage data, so preparing it, access it, and governing it. We provide tools also for developing models, so building, optimizing, and validating machine learning models. And we cover also the productionizing part. So taking the models, automating them, monitoring, and allowing you to retrain them. The platform can be deployed on any cloud provider of choice and has a lot of open source integrations. And particularly, it can add a lot of value when we are trying to embed, for example, our large language model in our applications. To illustrate this, I'm going to walk you through a use case we developed in collaboration with an American government and military contractor. Specifically, this contractor is hired whenever a new regulation is being discussed. And it has the role of collecting all the public commentary that has been made in regards of the regulation, analyze all this body of text, and come up basically with the key ideas that are embedded in the public comments, provide a summary of them, and ultimately produce a report. And this process is currently they do it manually, and it takes them 4,500 hours roughly to process all this data. Here we saw a lot of value of integrating SAS in this solution, and specifically by combining our SAS visual text analytics tool with large language models, we were able to decrease the times to just 200 hours. So in just 200 hours, you can go from your raw data into actionable insights. And we were able to achieve this through a set of different tools. So the duplication, extraction of key topics, extraction also of key entities to filter out the different statements. And let me actually walk you through the pipeline we developed to accomplish this. So we start with our raw data. So this is the regulation data and all the public comments that are surrounding it. Here, comments can oftentimes also be whole documents going through positive aspects of a regulation, negatives, as well as risks and opportunities that are there. We add a layer of SAS visual text analytics here, and the goal is that of filtering and keeping only the relevant statements. Really here, we're able to filter the data to just 1 to 10% of their original data size. So through custom entity extraction, we are able to identify the relevant statements describing actionable information on the regulation. And really having this VIA layer here is adding a lot of value in two ways. First, by filtering out and reducing the available statements, if we were now pass the data to a large language model, well, we have many less tokens in input that we need to process. So definitely lower processing costs. And more, we are going to have a much more focused context, which is ultimately going to lead us to better LLM generations. And indeed, this body of statements is passed to a GenAI model that is going to power some parts of a final dashboard. And the dashboard is also going to be powered again by SAS visual text analytics by adding, for example, sentiment analysis, extraction of key topics. But let us really see how this looks like at the end. So this is a screenshot of the negative comment section in regards of this specific regulation. On top, we have two GenAI generations. The first one is a summary of what the comments against the regulation or that are critiquing the regulations are saying. And right next to it, we have the top 15 key unique ideas that are embedded in the negative comments. What we see underneath, instead, is all powered by SAS visual text analytics. So we have a word cloud of the key recurring topics in this negative comment section. We can then, of course, click on one of them, and this is going to filter the rest of our dashboard. So we get a distribution of who is submitting comments specifically to this domain. We also get an idea of how many unique statements are linked with the topic, and we can drill down and look at the original comments that are concerning this specific theme. So now let us move to VIA Copilots and to a different use case. For this use case, I would like to present you what we developed in collaboration with a bank in the domain of complaints management. So specifically, we have this bank that is collecting complaints coming from different customers, and those come from web pages, emails, phone calls, and text conversations. And really to try and improve this complaints management process, they wanted a new system. They wanted a system that could allow them to summarize conversations that were made with a specific customer over different contact episodes. They wanted a system to generate a reply for this specific customer. And in all of this, we wanted to keep, of course, a human in the loop to be able to validate the email before sending it out. And of course, in all of this, they wanted to use large language models. But here, we really need to emphasize the fact that LLMs alone do not solve business tasks. Rather, we need to see LLMs as features, as tools that can add a lot of value, but that needs an orchestration process to be there to make sure that we can really generate value from it. And that's exactly where VIA is stepping in. And integrating VIA and GenAI to substitute business processes here led to tremendous impacts. Specifically, we noticed an increase of 20% in the volume of complaints that were now handled. We also note a decrease in the average response time thanks to SAS and large language models being there. And also, we notice a decrease in the cost of handling. Let me now walk you through how we do this. So we have our internal database where we are storing all our contact episodes for a specific customer. So if we go and take one customer interaction, so one entire customer interaction, we pass this to a large language model, and the large language model is going to generate a summary of the complaints, of the issues that the specific customer is facing. This summary is then fed to SAS Via, and specifically through SAS Via, we're able to explain what the generation is about, so drilling back what the generation is with the original complaint, and we can query internal data sources to enrich the information we have about the customer. So we're going to extract information such as the customer churn probability and the customer value. And with those information, we can now go to a decisioning engine, our own SAS Via decisioning engine, to recommend what should be the next best action. So for this specific customer with these specific issues that has a given churn probability and value, what should we do? After this decisioning system provides an answer, it simply prompts back the LLM with a very specific prompt for this use case, and the LLM is going to generate a reply for us. The reply is then sent to an operator for review, and then, if it is approved, it will be automatically sent out. Now, of this pipeline, what I want to emphasize is that the LLMs are there to summarize a body of text and generating text with a specific prompt that we are providing it. But really the value that is there is coming from Via. So adding a lot of explainability of what is being generated, as well as adding a lot of information on the specific customer, and then based on those, decide what best action to take. All right, let us now move towards the last building block, so synthetic data generation. And when we talk about synthetic data generation, here I have a use case we developed in collaboration with Nationwide. So Nationwide is a bank that is involved in approving loans. So it collects a lot of information on customers, and then it has its own machine learning models to try and predict if the individual is going to default or not on the loan. Now, historically, there are not a lot of defaulting observations in datasets. So what can we do about it? Well, here, there is a lot of opportunity for synthetic data generation to add value. And specifically, here, we saw a lot of applications of introducing generative adversarial networks to synthetically generate more defaulting observations. This had tremendous impacts. So we were able to improve the target metric of reference, in this case the Gini index, by 51%. And we noticed also increased precision for models, as well as an increased reliability. So if we look at the prediction variance, now it is much lower compared to before. And in this type of data, we really have different approaches that we can undertake. So the regional data has only 5% of the observations being of defaulting customers. And if we simply take this data and pass it to a model, well, models may have issues. During training, the relative fraction of defaulting observation is going to be quite low, making then the model receive a less stronger signal from the data, therefore potentially having issues and having models always predicting non-defaults, basically. To avoid this, one approach could be that of undersampling non-events. So if we undersample the event that we have in bulk in our data, the relative fraction of defaults rises. So models here are going to be more sensible, are going to receive a higher signal from defaulting observations, yet we are losing out on real observations that we could add to the model. We could oversample defaulting events. But if we were to oversample defaulting events, then the model generalizability will be impacted. We are going to have the same observations for defaulting customers multiple times in our trained data sets, which is ultimately going to make the model learn only of the specific customer and not on the general patterns that are there for defaulting ones. And so the last approach, which is the one we decided to undertake for this specific use case, is that of synthetically generating new defaulting observations. So this is done through generative adversarial networks. So we train a GANs model on defaulting customers to then generate new defaulting observations for us. The advantage of this, we create observations that are going to retain statistical properties of real defaulting customers, but are not going to be identical. So the model generalizability is not going to be impacted, so we reduce the risk of overfitting, but we increase the fraction of defaulting observations that we have, which ultimately would lead to improvements in model generalizability. Pipeline-wise, this is how we do it. So we start with our original data, so a lot of loans information on the client. We train our GANs model to synthetically generate observations, and this synthetic data is then passed, of course, to machine learning models. Now we can compare the performance with the baseline model that the bank had already in place. And if we compare it, we actually notice that our ultimate and final model led to a 51% increase of the target metric of reference, being, in this case, the Gini index. All right, let's wrap up this presentation, and I would like to leave you with 3 main takeaways. So as we have seen with this presentation, SaaS Via is there to help you enabling tangible value from GenAI. So we have seen in the complaints management use case how Via can integrate with large language models to really lead to tangible business value, reducing time to value, reducing costs, especially in that case in handling complaints. We saw how Via can build trust in large language models. So Via is there to augment LLM inputs as well as LLM outputs. So we saw this in the dashboard where by filtering a lot of statements prior to getting to an LLM, we get to much better generations. And then we can still add a traditional layer of NLP after it to really add on the explanations of simply having a summary generated by the LLM. And finally, when we talk about GenAI, especially with SaaS, we need to be aware that we are not limited to just large language models. So we can and should leverage synthetic data generation, especially when we are modeling for rare events. All right, this is it for my presentation. So thank you all for attending. Make sure to visit us at booth B96. We still have a couple of minutes left, so if anyone has questions, maybe we can take one question to make sure we are on schedule. So thank you all.
So indeed, we have, thank you, Fabio, very much.
Yep.
Very cool to hear from a data scientist working at a company that's been doing data science and enabling data analytics for over 40 years.
Yep.
Talk about the future of data analysis. So we have time for questions. Someone with a mic, I think. There's one hand here in the front. Right there.
Yeah, so my question is about the synthetic data. If you use a GAN for the use of synthetic data, the GAN itself also has a sort of bias, right?
Yeah.
How do you ensure you manage that bias to get a representative data set eventually for the synthetic data?
That's a good question. When we do synthetic data generation with our Via platform, we have tools there to make sure, to make sure that we can first monitor the kind of data we feed first to the model, and after we have generated observations, we are going to compare distributions. So to ensure that fairness is going to be there, we can compare it. So we have a different set of fairness metrics available, and that would allow you to potentially discard observations that would alter fairness or would not really add anything to the model, right? So comparing distributions prior and after getting to a GAN is a way to drop out observations that are not adding value but are simply leading to bias. And cleaning the data a lot before getting to the GANs model can definitely help you also with that.
So there's no human in the loop there whatsoever?
Well, you can have a human in the loop at the end. So once you have generated observations, you don't have an automatic deletion of records that are, for example, biased. But so you definitely are going to have a data scientist there looking at the observations and finally understanding what's going on, what kind of bias metrics we are looking at, and therefore take a decision based on that. So yeah, you must have a human in the loop there. Yeah.
Great. Thank you very much, Fabio. Unfortunately, we don't have time for any more questions. Thank you. I think you'll be around to take any other questions after the talk. Thank you very much.
Thank you.
Great.